Very good afternoon. My name is Jason Ma. I am from Diploma in Computer Science in Year 2, Sem 3, which is in Thai UMT. Today, I would like to share about the LED network design for TVC University College. Let's start from the introduction. Firstly, we have two buildings in TVC University College. One building at location A is for the department office, chancellery and management department on the third floor, administrative department on the second floor, finance department on the first floor, and last, admission department and marketing department both is on the ground floor. Another building at location B will be the faculty office. Next to the location A consists of 4 faculties. Faculty of Innovation and Technology, Faculty of Business and Law, Faculty of Health and Medical Sciences, and last, Faculty of Social Sciences and Leisure Management on different floors. For the overall network, we use the IPv4 addressing scheme for the network, and we use the two most of the popular private network, which is 192.168.10.0 for the department office and 172.16.0.0 for the faculty office. For every department and faculties, we have a switch that connects to the same router. Meanwhile, the whole department switch and the faculty switch, all of that 9 switches in the total is connected to one router at the middle. The router is used to connect to each other to the transfer and receive any data. As I said, there is one switch in every department and faculties, and there is also a PC as an example in each office connection to the switch. This is the example that represents one of the hosts that is configured the IP by the switch from the router. And there will be other and more end device in the following office depending on the requirement of the office in the future. So next, let us take a look at the host table, and let me introduce about the number of hosts required and the host bit. What is the relation about these two? For first, number of hosts required is the requirement that demand from the TVC University College, and the host bit user to calculate the available slot that is enough for the number of hosts required. For the chancellery and management department, it is required 20 number of hosts. It is using 5 host bits, which is 32 available host slot. Administrative department is having 50 number of hosts required. It's using the 6 host bit, which is 64 available slot. The finance department is using 20 number of hosts required, and it is using a 5 host bit, which is 32 available hosts. Admission department and marketing department is having 30 number of hosts required, which is available by using 2 power 5, which is 32 available hosts. So it is using 5 host bit. Faculty is having a much huge comparing with the department. So this have 2 pairs of data in each faculty. This is because the backward data is allowed the 20% of growth for the future use of number of hosts. So let us just take a look at the after calculated 20% of growth of the number of hosts. For the Faculty of Innovation and Technology, it is having the 720 number of hosts required. So we are using the 10 host bit, which is 1024. The Faculty of Business Law is using 10 host bit, which is also 1024. And the Faculty of Social Science and Leisure Management is having 480 number of hosts required. It is using the 9 host bit, which is 512 available hosts. And Faculty of Health and Medical Sciences is having 240 number of hosts required. It is using the 8 host bit, which is 256. So let us take a look at the subnet table. The subnet table is help us to calculate the range of the IP address that need to configure to all the intermediary device and end device. So let us take a look first at the prefix length. Prefix length is using the 32 bits of the total and minus the host bit, and we will get the prefix length. So here, the administrative department is using 6 host bit, and 32 minus 6 is 36, and the rest is using 5 host bits, so 32 minus 5 is 27. So let us take a look at the first example. As we know that the 6 host bit will be 64 available slot, and the subnet address is starting from 0. So the length of the range will be 0 to 63. So we can see the administrative department is having 192.168.10.0 as the subnet address, which is the first IP address of the range, and the last IP address of the range is 192.168.10.63 will be the broadcast address of administrative department. And the first usable host address and last usable host address is in the range of the first IP address and the last IP address. It is in the middle. So the first usable host address will be 192.168.10.1 until the last usable host address will be 192.168.10.62. So this is the overall of the department, and let us take a look at the faculty. The faculty is using another most popular private IP address, which is 172.16.0.0. And let's take a look at the prefix length first. The prefix length of the Faculty of Innovation and Technology is 22, which is 32 minus 10, and we get the 22. So we know that the host bit is 10 and the available host will be 1024. So the range will be 172.16.0.0 until 172.16.3.255. So we can see the first and the last will be subnet address 172.16.0.0. The broadcast address is having the last, which is 172.16.3.255. The first usable host address is in the range of the first 172.16.0.1. The last usable host address will be 172.16.3.254. So this overall, all you can see that. So that's all for my part, and I will pass to my teammate, which is Teo Mo Ching. So thank you very much.
Hello guys, my name is Teo Mo Ching, and I am from UMT FCN TCS2, and I'm going to continue our explanation about the network design. So we have the addressing table. For addressing table, it provides the information of the device, interface, address, sign mask, and the default gateway. We have two tables at all. One is for the left side, one is for the right side. So for device, we only have router with router 0 connecting to the 9 switch of, and we have each switch we also connect one PC, which is an example for the end device. Then we have the interface. For the router, we have the gigabit internet 0010203040 until 80, which is this line connecting the router and the switch. For the switch, we will use VLAN 1, or is the same to connect to the PC. For the address, we use the host given, which is we after an calculation, we calculated the host the address, which is the first one. For example, we start with the first usable host address is 64 usable host, which is 64 available slot in total. For the second one, we have 32 for the 30 hosts. Each part is its own calculation. It's the same for the right side one. And we have switch 0. We start with the second usable. We start with the second usable host address, which because the switch has user 1, and we start with the second. It's also the same. 64 usable host address, and also the calculation depends on the host given. Then we have the sign mask. It's also the same. For the first one, as example, we have 6 host bit, and we have calculated 255.255.255.192 for the 6 host bit. For the second one is 5 host bit. Depends on the calculation for the third, second, third, 3, and 4 is the same. And for the right side, also a calculation for each is given, depends on the host. Then lastly, we have the default gateway, which for the switch 0, we start with the First suitable host address, same as here. We have the same calculation and the same things at all. Is to define the gateway and to start where to start the slot given. The same as one as the right side. And next we have the ping connectivity between end device. It is the connection between the PC and PC. It's mean the end device and the end device. So you can see this is a PC0. We ping with the PC1. As an example, you can see this is the result we have taken for PC0. We use the command prompt. This we are at C0 right now. You can see we're going to ping the PC1, and the PC1 is we're going to ping the PC1. Let's just try again. Yes, it is successfully print as same as the result. So that's it. And we can see I have pinged PC0 to PC1, 2, 3, 4, 5, 6 until 8. Then for PC1 we start with PC2 until 8. PC2 we start with PC3 until 8. That means we for the same connectivity like PC0 to PC1, if we have success to ping it, that means we no need to test the PC1 to PC0 again, because it is tested and it will be repeated the same result. Yep, that's it for my explanation. Thank you.
Thank you, Moching. And that's all for us. Thanks for watching. Bye bye.